Do you see recording button?
Yes,
No.
yeah.
Recording button.
Showing.
Okay, this is great.
So did you start?
So, yeah.
There is no recording from my side. I don't know. Maybe.
Do you see the red button somewhere?
No, till now, no. Maybe we can ask our attendees too in order to confirm that.
It has started, I think. I see a
Yes.
notification.
Okay.
You seen it? Okay, this
That's
is great. Okay, great. So, dear all, I would like to welcome our tutor attendees and SPWLA Iraq board member to our webinar number 7 in 2025 in regards to machine learning utilizing GEOLOG software. My name is Mazen Al-Hilali, a senior petrophysicist working with Look Oil International at the West Gunna 2 project in Basra, Iraq. And currently I'm the SPWLA chapter chairperson. I will leave the floor to Dr. Mohammed Jawad, VP of Technology with SPWLA Iraq for a speech. Dr.
Thank you.
Mohammed,
Thank you,
the floor
Mr.
is yours.
Mazen. Okay. Dear distinguished guests, it's my pleasure to welcome you to today's session organized by the SPWLA Iraq. My name is Muhammad Jawad Zainul Abedin and I serve as the VP for the SPWLA Iraq. I hold a PhD in petroleum engineering and am a senior faculty member in the Department of Petroleum Engineering at the College of Engineering, University of Kirkuk. Today is Friday, the 29th of August, 2025, and we would like to present the 7th edition in our ongoing webinar series. This session is entitled Machine Learning Applications in GEOLOG Petrophysical Software and will be delivered by Mr. Brijesh Kumar Singh at Aspen Technology. Welcome again, Mr. Brijesh. Dear attendees, we would like to bring your attention some significant points. Kindly close your cam and mic during the webinar. The session will be recorded. If you have any questions, please feel free to type them in the chat box. The lecturer will answer them during the question and answer segment at the end of the webinar. Additionally, please note that during the presentation, we will share a link in the chat box to join the SPWLA Iraq on LinkedIn. Thank you. Mr. Mazen, the floor is yours.
Thank you, Dr. Mohammed, for the speech. Mr. Brijesh just will make like a very short presentation, okay, for this event, for our upcoming event, okay, before we start the lecture. Is my screen sharing?
Yeah, we can see your screen.
Yes.
Okay, so welcome again to our 7th webinar of 2025 SPW Iraq theme, which is focused on artificial intelligence. Our special thanks to Mr. Brijesh Kumar Singh and for Aspen Technology for their volunteering efforts to provide this webinar about machine learning application in GEOLOG software. This is our 7th webinar this year. All these webinars have been published on YouTube. So if anybody missed this webinar or any one of them, he can watch them on YouTube. We'll give certificate only for the people that physically attend, okay, the webinar. We expect to hold 3 more webinars this year. We'll keep you informed, okay, with Baker Hughes, Crested, and Microsoft. As every year, there will be a special learner certificate for any attendees who attend 6 or more of our webinar to be awarded in December 2025. And you are very welcome to join Iraq chapter through spwla.org officially. Question and answer to be kept at the end of lecture. And as have been mentioned by Dr. Mohammed, kindly keep your mic and camera closed, mic muted. Thank you all. Mr. Brijesh, the floor is yours. We'll appreciate if you kindly start with introducing yourself in more details. Thank you so much.
Thank you, Mazin, and thank you, Dr. Mohammed. You have already introduced me, but that I'm working in Aspen Tech. I have 20 years of experience as a petrophysicist, and today I'll be, sharing the workflow within GEOLOG software, Aspen Tech GEOLOG software for machine learning, which is basically used for rock typing and log prediction. So I'll switch off my camera so that we don't have any interruption in between. Please confirm if you can see my screen, and then I'll start the presentation. Yeah. So I'll start with the presentation, and if time permits, we'll have a quick live demo so that you can see how we run it. So I'll not definitely show all the workflow, but there are some pre-recorded workflows which I can show examples at the end. Okay.
Okay, I believe we can start your screen sharing.
That's good. Yeah.
But not right now the PowerPoint, but it's not in full PowerPoint mode.
Yeah. So you can see the full PowerPoint, right?
Yes, right now, yes. Okay.
Good. So
yeah, thank you.
So if there is anything you can interrupt in between, Mazin. Okay.
Yeah.
So
Yes,
I'll start
please.
my presentation. And
yes, please go ahead.
I want to thank SPWLA Iraq chapter year by year doing this knowledge sharing session for the community is quite helpful, and I'm always glad to be part of that.
That's really
So
appreciated.
today
Thank
what
you so
I'm going to discuss about is the ML machine learning. Now we are everybody is coming with a lot of AI also, and now everybody is quite aware about ML and AI. What is the distinction? So today we'll be talking mainly about the ML part, machine learning part within GEOLOG. You know that GEOLOG software is basically formation evaluation software. Anything which we record in the well, so we can process and interpret anything. So today our focus will be mainly, on one of the tool we call it, a face image, and the benefits what it provide and where it's had, a distinct differentiation from other technologies. Okay, so you can see that we can incorporate all the data, and that's what advantage of face image is that core data, log data, any array data like NMR or image or scale, so it can incorporate everything within that. So that's the biggest advantage here. Okay, so we know that when we are talking about the main application of ML GEOLOG is basically electrophysics analysis and rock typing, and the definition of rock typing or the clustering on based on certain properties can be different for different people. So it can be a reservoir rock type, or flow units, or lithological rock types, or sometimes textural rock type, so mechanical rock type when we are talking about geomechanics. So the rock typing is basically typing of your rock or reservoir with certain kind of property you want to see, and the key thing is that there should be an option to integrate any kind of data. So you can, other than the logs which we have continuously in the well, we can integrate all other data for effective rock typing and train our data on the log using machine learning. So I'm not going to discuss much about the rock typing workflow. It's very extensive topic, and how we integrate and come up with different kind of PRTs or RRTs or lithological rock type. But whatever rock type you attain at the end, in certain number of well based on very high end data like core, NMR, sedimentological data or textural data, is say with only few wells, because all those advanced data or studies like scale, core, or these are recorded in few wells, and then as a petrophysicist, it's our job to train this data with the log and use ML technology to predict this in all other wells. So similar thing goes for even permeability, so log predictions. So we have core data in certain number of well, we have testing in certain number of well, and we have to make sure that this is populated in other well, and that's what we'll be discussing. Okay, so the other advantage of face image, as I said, most of the technology in the industry, they take the log data, they take the core data, but face image can also take any kind of array data, which is the biggest advantage of face image. So you can take NMR as an input, you can take image data as an input, you can take a scale data as an input. to do any kind of integrated rock typing or rock study. Okay, so when we talk about the phasiness, we have 4 different methods. You can see classification algorithm. Okay, some of the old ones, analytical clustering, dynamic clustering, and then some of the latest one like self-organized map. But what we always differentiate ourselves from other is that we have one of the most latest and advanced one, which we call it MRGC, and we'll discuss more about that. And as I said, it can handle any kind of data with core, discrete, and array data. The third part, which is quite important, is that when we are predicting using ML and predicting in applications well or new well where we have data scarcity, we need to know that there is a similarity between the log, because log are the main engines where we train our data, and then we predict the phases or logs in other wells. So similarity is quite important. So we have a machine learning technique, we call it similarity threshold method within the phase image. So other than the clustering methods, we have STM method, and it can be quite useful both when we are predicting phases and otherwise when we are predicting the log. Okay, so as I said, phase image can also predict phases and log. It can be it has both the use case together in the same workflow. Okay, so what is MRGC? I'll keep it very simple. That it's based on the dot pattern recognition, quite natural. It tried to create a data structure or groups based on the underlying structure of the data. So we are not forcing the data that we want 10 or 15 or 5 phases, but it's try to start a clustering based on different kind of data density, shape and size, and relative separation. So it's quite independent in doing that. So it's not what we can say, it's not biased. So that's the key message here. Okay, there are some other methods like self-organized map. Many people use it, and this method is used to produce ordered low dimension representation of the data. But one of the important thing is it needs some starting point actually, that how many number of cluster of phases you want. So somehow this is one of the advanced ones if you compare with other methods, but still it is dependent biased by the interpreter. Okay, we have dynamic clustering also, uh, quite old one. Okay, and this depend basically on predefined number of clusters. Okay, and dairy centers. And the last one is hierarchical clustering. Sometimes we use this for even log also. So this is based on a statistical method for finding a homogeneous cluster. Again, a pretty old one. It has been used in past, but as I said, because we have 4 methods, you can use any one of them. But why we always say that MRGC is best? Obviously, the last point which we say, faster and larger data set, has somehow become more irrelevant because now the computing power has increased. But the other 2 things, like no prior knowledge required, no operator bias, so that's what make MRGC quite important. And we'll see there are some additional benefits why MRGC or multi-graph resolution method, graph-based method, is quite had quite a lot benefit in comparison to other methods. So what and how we do, very quickly, as I said, is naturally create a cluster based on the underlying data structure, and 2 important factors are basically the local density, which we call it neighboring index, and then the local mode of probability, how dense it is, how it is represented. So based on that, it try to create a lot of clusters. So it doesn't give you a single cluster. It can give you multiple number of clusters based on your data structure, if you want lesser number of cluster or you want more number of clusters together. So what is trying to define is based on the KRI index. You can see some inflection point on the data. Okay, so if you want to say that I want only 2 clusters, it will see the biggest inflection point, and it will divide it to 2. If you want, say, okay, give something between 0 to 10, so it will try to find somewhere in between other inflection point based on the KRI partitioning. So you can ask MRGC that give me 5 different models ranging from 5 to 35 clusters, so it will try to find those clusters. The best way what we do is we take the highest number of cluster or biggest number of clusters and start merging them based on the geology. Okay, so it's try to solve the geological problem. Okay, so again, we select the data set, and based on the two key parameters is try to cluster itself, and based on KRI we try to find number of cluster which we want to define. So as we increase the NNI range, is try to cover more and more data actually and give clusters. Okay, so so what is the advantage of MRGC over other methods? First thing is that we know that there is a dimensionality problem when it comes to log. Okay, you can see that this is a simple example, that this is your sandstone line and this is your limestone line, dolomite and then shale. So these 2 points, if you are doing any cross plot analysis, these 2 points are more closer. Okay, and these 2 points are more further. But if we talk about the lithology or phases, these two are more similar than these two ones. So we have this kind of dimensionality problem, and how we solve it with MRGC is that we first divide cluster into larger number of clusters. Okay, and then we try to slowly merge them, that which are more closer to each other. Okay, so this can be done both ways, like unsupervised and supervised. So you can just create electrophases and merge on your own, or with supervised technique. If you have some sedimentological data, if you have defined the rock type, you can train your electrophases to those phases. So both way you can do, but it solves those dimensionality problem. Okay, the second thing is this MRGC is clubbed with SOM. Okay, we call it course to find self-organized map. And what how does it help is that it try to rearrange your phases in a sequential manner, so that phases number 1 and 2 and 3. So even when you see the dimensionality problem, okay, if this is the phases number 1, it will assign 2 to this one, okay, and 3 to this one. So you know that which one to merge. Okay, so that's what your CFSOM method do. Basically is try to choose the sorted path on the log, and try to see that which are more similar, so that at the later stage that you have to only merge the sandstone with sandstone, silt with silt. So it arranges in a similar way, so that you don't have to find and merge phases number 1 to 8. Okay, uh, the workflow, basically the basic workflow is same. Like first we have to define what we want. Okay, what kind of rock type we want. So if you have already done some reservoir rock typing, you want to train that on your log and populate in other well. Or if you are doing a rock typing for unconventional or mechanical geomechanics, or just for geology lithological rock types. So first is of defining objective, cleaning your data, choosing your uh, best wells, which are the well we have, where we have all the data to train it. Okay, so that is the most important thing. So as I said, our objective may be different based on what kind of rock type we want. And then the second thing is that we have to choose wells, some of the wells, a few wells where we have the richest data and all the geological information you want to predict. Okay, so the next is train the data in the training wells. Then use so when we are doing the modeling phase, we are using all those 4 methods for clustering, if you want, or any one of them. And then propagation, again machine learning or KNN mode, where we apply those phases to other wells, using propagation method. Okay, so in between, we also QC that with the core data. We check the similarity, which is another, a machine learning method. So we use machine learning at multiple stages. First is the training or modeling, where we use MRGC or SOM, or if you want to use other methods. The second is obviously, doing, creating, similarity and running, similarity, and see that whether the logs which you are used to train are similar or not. And then finally using the application, like propagating it other wells, k nearest neighbor method or very center method. There are 2 methods available. Okay, so this is a typical workflow. We add the logs, we do the normalization, we create the model, and finally we propagate the model. Okay, so this is the input, and as I said, you can add any kind of log, whether it's discrete or log, and create a model electrophysics and calibrate with core or anything else. If you want to do a supervised rock typing, and if you have rock type from created from scale and sedimentological data, you can add those and do a supervised electrophysics analysis and rock typing. Okay, so these are two main inputs. First is the log which need to be trained. Okay, and third, second one is the logs which are basically a reference log to train your data. Okay, so here we can add permeability also if you are predicting the log. So if you are predicting phases, you can add phases. If you are predicting log permeability, you can add core permeability. Or if you want to use the same model, you can add both. So with the same model, you can do um, uh, rock typing prediction or permeability prediction both. Okay. So how we do it in supervised, unsupervised is obviously electrophases, just the phases created from the log. You can choose the maximum one, start merging them and seeing which is the best, phases based on the information you have. And the second one is if you have added your phases, core phases, which I was showing you here, okay, say 4 phases, you can choose any of the electrophases and train them, okay, with the log phases, okay. And this is basically what we call supervise, and we can train them. We can see if there's some merging is required between them, with how the contingency table is suggesting you based on which of the electrophases is assigned to which of the rock types. Okay, and when we click OK, all the electrophases are basically converted to your rock type, and you can predict it in application wells. Okay, so this is the first step, as I said, is creating using ML technique to create your phases. As I said, we have 4 different methods. Okay, we can also create STM, which will basically check your similarity between the log across all the training wells and all the application wells, and then we can run supervised training. Okay, so when we did the supervised, it will automatically create 4 or 5 phases, whatever you are training. You can assign colors, you can assign codes, numbers, whatever you want. And then finally you go for propagation. So here we have already done supervised training. So this was the core phases we used, and this is the final trained phases you can see. So you can fine tune it by different electrophases method. You can run the MRGC multiple times to have maximum number of phases to train and do the supervised training. Okay, so this is basically what we are doing, is doing supervised training to train electrophases to rock type. Okay, one of the most important thing what I said is similarity. This is our QC tool, and what it does basically is try to see all the input logs which are used for training, say gamma, Newton, density. These are the 3 log you are using across all the wells in your reservoir, whether it's training wells or application wells, how similar they are for a particular reservoir. Okay, so when you run this method, you have criteria to define how strict you want your method to be. Okay, so if you say 95% acceptance, you are keeping it very high similarity, and it's a good thing that you keep it very strict. 90 to 95 is basically ambiguous, but still you can believe it. Anything below 90, you don't believe it. So either the log is bad or new phases has encountered. So the more stricter parameter you keep, the higher value, the better it is, and then you can check how the model data or the training wells match with your application well logs. Okay, if the logs are not matching due to some other reason other than the phases, it will give a crap phases in the new wells which you don't want. Okay, so this is one of the biggest advantage QC tools in PhaseMate. Okay, how it does, if you are choosing 4 logs, it will try to see the similarity between all the 4 logs together, because all the 4 logs will be used together to see and predict the phases. It will also create multiple combination of 3 logs, 2 logs. And why we do it, we do it so that we can check that which is the best combination of log, which will give you the best training, and which will give the best prediction. Okay, so that's why it's quite important. If you have 5 logs, it will first break into 5 combined similarity, or 4 different 4 combinations. So it's quite healthy and quite useful when it comes to choose the input log which will be used for training. Okay. In recent release, we have also added another feature which will tell you the best combination of log additionally to QCO2. Okay. So when we are running this similarity, we can run it in multiple wells. Okay. We can plot multiple wells together. On the layout, we can see single well. On the plots, we can see them. So you can see how similar the data is. The more red you see, it means there is similarity. The more green you see, it's more similar. So when the similarity is there, it means you can have confidence in your prediction of phases or logs both. Okay. There's another thing. So because as I said, there are multiple ways of doing clustering, and some of the logs are not available everywhere. Okay, like NMR, like ECS, like image. So what you can do is you can make two different model for phase image, one with NMR, one with image. Create different cluster from them, and then you can combine them in the third model where you use all your basic log to train those phases coming from NMR or any advanced tool to create a final phases. And because the third model will have the log as a basic training, you can use the phases coming from NMR or any other tools to train in other ways. So this is called synthetic modeling, where you combine output from two phase image to third model. Okay. So you can see we can we can use NMR and we can create phases from NMR for if in case this can be useful when you are predicting permeability, or you want to know more integration with the log data and core data. So sometimes NMR helps in that those cases. Okay. So once you have created your model in one well, you can use machine learning to predict it in all other wells with similarity. So you can predict where. So in this well, we had core control, and we predicted in other well where we don't have core, we can just predict. And remember that GEOLOG is multi-well, so it can run 500,000, 5,000 well in one go if your data is quite clean and structured. The second case for machine learning in GEOLOG, and whatever method we talked about, is it can be also used for log prediction. Most of the time when it's log prediction, we talk about predicting permeability using the core data, or if you have permeability from any other source. Okay. But it can be used for any kind of log prediction. I've seen for DT, for Robi, in case of somebody is doing inversion, they want the continuity of the data. So any kind of log, obviously the best use case is permeability prediction. Okay. So we can use any of the clustering methods to do clustering, or directly we can use the entire data. Okay. And then we can train the data and do prediction based on the KNN or Bayes interest. So this is quite old method. The results are not that good. KNN is more latest one, more improved, and it's give much better results. So it can be used, the same clustering techniques, machine learning can be used for log prediction also. And it also come with additional log reconstruction. Other than the similarity, it's also come with log reconstruction technique, where you can get mean and max, and you will have had idea about how the prediction is. Okay. So you can get two ways of QC in case of log. One is similarity and other is log reconstruction. So what we see when we are predicting permeability or any other log, that we get minimum, maximum, mean values. You get you get to know where we have a smaller range of the data, and together with similarity, you know that whether you have confidence on predicting or not. The rate doesn't mean everything you can just negate, but you need to QC that area, why there is no match or why there is no similarity. Maybe the input logs have some issues, maybe bad hole is there, so we need to fix that and run it again. So log prediction, again, all the four methods can be used to do phase clustering, and then same cluster can be used to predict the log, or you can take the entire data to do log prediction. Okay. So two different ways of QCs here. Okay. So what we want to achieve at the end, okay, using all these machine learning techniques. So first is obviously we want to make sure that we can do electrophases, or we can train these electrophysics with any kind of rock typing, core data coming from core, sedimentology, MICP. So if you have rock typing from that, you can train and come up with a continuous rock typing in the wells where we have data, and in other wells you can populate it. Okay. And then the third is basically you can do permeability prediction or log prediction. So a lot of use cases are there with a lot of QCs, as I said, which is similarity. Okay. So I'll quickly go to GEOLOG. Okay. So that you can get a feel about what we are doing. Okay. So let me see that. Okay. So I have prepared some data. Okay. First, what I will do is I will show you how to create the model quickly, and then I have already some examples. Okay. So you can see this is one of the well here where we have some basic logs available. Okay. We have some core data available here. You can see we have some lithology which is coming from core. Okay. So you can see we have defined it simply, but you can have sedimentological data and different kind of rock type name. So all this data is available. Okay. So how we use face image? Okay. First we open a blank face image model. Okay. We can add multiple basic logs which will be used for training your data. Okay. So we can use gamma and density. So I'll just show you a few examples, not many. So what I'm trying to do is I'm trying to choose. So I'm not discussing about rock types. We have already done some rock types and we have all those data available. What I'm trying to do is trying to show you machine learning technique, how you can train the data and populate in other words. Okay. So I have taken 3 logs, and we should always take this input where when it is available in all other wells, because this is the dependent data. Okay, which will be used for training. Okay. So in case you want to do supervised training also, you can just add the rock type which we have created already. Okay. So in this case I can just choose this rock type. The next step is just to add the data. Make sure that you are choosing the rock types. Okay. You are choosing the reservoir where you want to predict this data, where you have actually the core data. So we should not do well always. It should always be zone wise or reservoir wise, because then the similarity will happen quite well. Okay. So what we do, we add the data. You can see it will tell you how many number of data are there. Some sample might be outside the limit, so you can just remove data outside the limit. This is your phases which can be used for training. There are multiple methods for normalization. Now you can see that when you are adding the training data, the scales are different. Okay. So when everything, all the data need to be combined together, they need to be in the same scale. Okay. So that's what we have normalization method, multiple mathematical methods to normalize in the same range, so that when it's go to 2D space, you can do the clustering using all the ways. Okay. And then finally all the techniques here. You can see we have SOM. So as I said, in SOM we have to define the number of faces. So you can run it and it will create faces. You can see and that it has created 25. If I go and I say I just want 9 faces, so I can do that way. Okay. Certain combination. Okay. Or 6 basically you can see, so it will create. But dynamic clustering also, it will require how many number of faces you want. Okay. So these are all method. What we suggest always is MRGC. Okay. Here we don't define how many number of faces you want, but we just say that minimum 3, maximum 35. Give me 5 different models, and if it can identify 5 model, it will give you. Okay. And this is the nearest neuron for finding the sorted path, and this should be 1/3 or 1/4 of the minimum. Okay. So we can do this way. So what it will do is, instead of giving one kind of electrophysics, it will give you 5 different models. But here you didn't tell MRGC that you want 6 or 11 or 7 or 21. It's basically based on the data structure itself. Okay. The next step is you can run similarity. As I said, I can keep higher values and keep it run it in this well. So I'm just taking one well as a model well, but we can take 4 or 5 wells also. So what we do when we have to do unsupervised phases classification, we just take any of the model here, like 6 rock types, and I can just give output set name. Okay. So when I just give output set name and propagate it, you can see this phase is calculated in your database here. Okay. And how we can check how the phase is coming? If you click here, it will create a layout for you. Okay. You can add this layout in any of your layout where you have all the data. Okay. And QC your results and see that whether some kind of merging is required. Okay. So you can compare with core data, you can compare with your logs, you can see all the phases are good or not. So all those things you can do. Okay. You can display it clearly. Like if I see that this green and yellow are together, the same same rock type, then there is an option to merge it. So I can see when I propagate, I can see the color code here. Okay, on the model, you can see here. So I can open the model, bring it here, and I can see it color coded based on the rock type. So you can see the cross plot. You can see the results, and I can say that okay, I want to merge these two to be same. Okay, so I can go here, go to my data, and I can say that okay, merge these two. Okay. So I can say just merge these two. Okay, or maybe these three together, so that we have minimum number of faces, and then I can just go and propagate it again. Okay, and then you can see the result. Okay, that these are all similar. Okay, these are different. So this is way of doing unsupervised training. But in case if you want to do supervised, like supervise this with any of your existing rock type, which we have already loaded here. Okay, so you can see that I can just click on this one and it will try to train your L-prophases with rock type. So do the supervised training. The best is always choose the maximum one, so that it can distribute or define small clusters which can go rightly into the same rock type. Okay, so I am just clicking assign, and you can see that 4 different phases are created, rock types now. Okay, and you can just populate it from here. Okay, I'm not renaming it anything, I'm not doing any coloring, but you can see, say RRT. Okay, and populate it, create the layout. So I can copy it and review the results. So this will become your rock type actually, because you have trained with your data. And once you finalize and you are happy with the rock type, you have integrated with core photos, image, whatever you want to do. You can just later on go and assign different color and codes, whatever. After finalizing, you can choose which pattern you want to use for that. Okay, so there are patterns basically, which kind of rock it is. So once you finalize, you can do that. So right now what I'm doing is I'm trying to finalize it in one single well. Okay, which is my model well, and this model is already built in this well. What if I want to populate it in new wells once it is final? Okay, so I can go to, I have some example here, you can see. Okay, so I can just go add more wells, and remember that these wells were not part of the training, and I can just run it in all the wells together. Okay, so there are multiple models and similarity methods. I can run everything in one go and then check my data. Okay, see. So this is your similarity. Green means good, and red means bad. So this is the well where we had created our model. Okay, so let me see where is all the comparison. So this is the well where we had created multiple electrophases and then rock type compared with core. This is similarity, and I can just go to the new well and check how the similarity is looking, how my rock type is created, and this is another well with maybe some core data which you can use it as a blind test, and all the electrophases which can be later on converted to rock type. Okay, there are some other well where there was no core control, so you can see the similarity. I mean, similarity means all the 3 or 4 logs we have used and your rock type or electrophases. Okay, so you can see that in some of the well, this red color indication means there is some issues with the data, or these are new phases, and you can redefine your models and try to predict. Okay, so in this well, what we had in this model, what we had done actually is we had used the rock typing logs to create electrophases and rock type. There are some examples where we can add we can do the permeability prediction. So the only difference is in this one, okay, is that we have to, instead of phases, we have to add permeability for training. Okay, so what we have done in this is we have taken input logs, okay, and we have added core permeability, and to train this core permeability in this well to predict continuous permeability. Now, which zone we have to use? You can see the training data that it has been done in these 4 zones. So we should select the zone before running it. Make sure, because we should run always in the zones where we have done the training. Okay, so that's one of the important thing here. Okay, so simple again. We have added the data, we have created the models, we have created STM, we go to propagation. Now, when we are doing the log prediction, okay, there are two ways of doing it. So as I said, there are 2 methods. So when we go to log prediction here, you can see barycenter and KNN mode, which is now everybody use KNN, which is much more superior. Okay, so you can see that these are the log prediction, and then the next important point is uh, when we are predicting this one, we can define how many number of basically the nearest neighbor we want to put. Okay, yeah. So if you are doing 1, means it's taking point to point data. If you are doing 5, it means it is averaging up to 5. If you are taking 10, it's averaging up to 10. So you can use and run any of them or all of them and see which is doing the best prediction. Okay, so if I run all of them, see, so you can see that this is the core data. Okay, and these are the prediction. As I said, if you choose k nearest neighbor 1, basically you are trying to match point to point. Okay, so this will be your match. If you choose 5, then there will be some smoothing. Okay, so based on how much data you have, if you have a lot of core coverage, you can use the minimum number of k, okay, nearest neighbor here. Okay, 5, or you can use 10. But sometime if you have sufficient number of data, you can use 2 or 1 also. Okay, so now one of the important thing is that when you are taking 5 or 10, not 1, you can create the layout, and you can see the back prediction of the input log. So this is another QC when you are predicting your logs. Okay, so it will back predict all the input logs, which will indicate how the prediction will be. Okay, some zone will have more uncertainty, some less, and this will be your prediction of logs. Okay, so this one is your core data. Actually, we can represent it as point data. Okay, and see how the match is. Okay, as it's quite important that you match the core data with your log. You can see the prediction here. Okay, so this is the use case of doing both electrophases, rock type, and log prediction. It can be we can use core data as an input for permeability prediction. We can use sonic or density, any log to build a model and predict in wells where we don't have data or bad holes. So to improve the logs, so these are some of the use case. So there's another quick use case. I still have some time, so I'll quickly finish that. Okay. So this is another example. Okay, in this well I had some core data. Okay, some scale. Okay, so what is the use case here? We can use the scale data, we can use the core data to do rock type, and the same rock type can be used for permeability prediction. So you can see that when we have pore and form, we can do just one single regression and try to predict permeability, which is not a good way of doing it. So what people do, they do first the rock typing. So there are different methods, as I said. One of the method maybe doing Winland or Pitman, and define your rock types. I have already set up some parameter, but I can change it, create 3 or 4 or 5 as much as you want. I have done it 3, and I can output like say I want to create Winland, so I can create 3 rock types, flow unit rock type, whatever you say, and create a Winland plot, Winland rock types here. Okay. So, and I can go and select that here. You can see that I can try to see whether my rock types are first correct or not. So I can split my data, okay, and see it on the scale data whether my rock type are good or not, and creating those differentiation or not. So I can do it for pore throat, which can be calculated in GEOLOG. Very easy to do that. I can use RCA pore form, or I can use scale pore form. So you can see that whatever rock type we have created is quite good. So we have calibrated with other data. Okay. Now the next step is use these rock types. Okay, to create pore and form relationship, and do the permeability prediction. Okay, for each rock type. But what happened, because these are point data, so it will only create permeability at only those points. So what we do, again, we use face image. Okay, to create faces, train the Winland faces, the faces coming from Winland. So we can use that as a input with the logs, and we can propagate it. We can create MRGC model and propagate to make it continuous faces. So when you go and see, what we have done is we have used uh, the core rock type coming from the core, and created reservoir rock type. Okay, so let me run it properly here in all the zones. So you can see we have created rock type here. Now all these rock types which you have generated from Winland are now continuous rock type, and whatever equation you generate from your cross plot for different kind of different kind of rock type, you can just run them equation, run those equation in evaluate, or you can just write a log learn. Okay, where you can define all those equations for each rock type and then calculate permeability. Okay, so when you do that, this is another way. But here, what is the use case of machine learning is you are creating those rock types and equations in these wells and populating those in all new wells. Okay, so you can calculate this permeability and predict the permeability. Okay, so I can just go to top, select the top, run this permeability. So let me see where it goes. So you can see. Let me see why it's not coming. Okay. We see what we have done. Maybe we have not chosen the rock type while running this one. So let me do that. Yes, and then the face image model for rock type. And then this equation. So anyway, so the purpose here is to calculate based on the rock type and permeability equation. You can calculate your permeability. Okay. So I can check that later on. But the third step is still it will have some uncertainty. The third step is directly predicting permeability from the core. Okay. So when you do that and propagate it, you will see much better map of match of permeability. Okay, and this you can run it in all wells in one go. So there are two ways of doing it. One way, or one is just having the equations and uh, have a continuous rock types and use those equation, or directly using phase image for permeability prediction. Okay, so multiple ways of doing it, as I said, and creating either the rock type and permeability prediction using phase image. Okay, so this was all, I know, very quick. I just wanted to give you a brief highlight how we can do and how we can integrate. Okay, so as I said, we can add, even we can create a phase image with scale data, which no other technology can do. So you can input a scale directly as an input, or pore throat as an input, and create a rock type. Okay, so now uh, I've tried to show everything, all the use cases. If there is any question, if any comment, I'll be happy to answer and discuss.
Okay, thank you for your informative and fruitful lecture, Mr. Brijesh. And we can start Q&A session. I believe there is some question in the chat box. If you want to take a look on them.
Yes, sure. So let me see.
And anyone can raise its hand
Yeah.
or jump directly, but please introduce himself or herself if you want to go directly to the mic.
Yeah. So I think this question, if I understand, this is something which is related to, I think there are two things. So one, we do the similarity, which I have already discussed, to find the correlation between, or similarity between blocks.
Sorry,
Okay.
Brijesh. Brijesh. You will start question from
yeah. So I'm discussing this. Okay.
Which question?
I think there's question from Anis, so Mohammed Anis. So I'm just trying to answer the first question.
Mohammed Anis. Okay.
Okay.
There is one question above it. There is one question above it actually, from Ja. If you go a little bit up. Okay. If you sorry.
Okay. So I think, yeah. So I think this question is about, if there is some other method like, random forest or those. So right now, no, in phase image we don't have those propagation method. We have still only barycenter and KNN. So yeah, we are discussing, to add some more method in coming years, but right now it's not there in GEOLOG. Okay, phase image. Okay, and then second question is a correlation matrix. Sometimes people call it confusion matrix. Similar to what I have shown in correlation here. So when we see the model, okay, let me see some good model actually, so that I can show you. So when we see the model, comparison between the model, okay, like here, if you go to the model, you can see the comparison here. Okay, so this is basically contingency table what we are talking about. So it will try to see how much is the correlation based on the number of sample points, or percentage, or probability, decreasing and increasing probability. So, and finally assigning them to a particular kind of rock type. So uh, people call it confusion matrix. Something, yeah, we call it contingency table here. Okay, so two things, this is the way to correlate, or correlation matrix what we are calling it. And obviously there is for correlation of logs in other application and training well, we'll call it similarity method. Okay, so there is another question: can I transfer cutoff value from Aspen to Petrel without any change in the input or process data? If somebody can repeat the question, because I don't know what cutoff we are talking about, but anything, any rock type we are generating here can be transferred to Petrel.
Yeah. Luis, you can ask your question directly if you like. Luis Mingwell. Or maybe you can answer question.
Yeah. So anything we create in other than the workflows, any output we create in GEOLOG, whether it's any rock type or electrophysics or anything, can be transferred with to Petrol because these are outputs. Okay, the rock type can be taken there as a number or as a name, physics name, whatever ways you want, because GEOLOG create that. And remember that GEOLOG has connectivity with Petrol. So if you have installed, in the same environment, Petrol connector, so it can be directly transferred even without, exporting it outside. So it can transfer all those phases and all the log directly to Petrol. Okay.
Okay. Ahmed Khalid is asking if he can. I believe he asking for demo license, if I understand the question correctly.
Yeah. So yeah, we provide definitely, demo license for testing. Um, uh, uh, to people, who wants to evaluate. So I've already shared my email. So if you can note down my email and write to me. Obviously I work with my team and see how we can help you. Okay.
Okay, this is great. I have few questions from my side. Okay.
Yeah. Yeah.
Before
Please.
conclude, first of all, GEOLOG is a very amazing, well-known software, mainly for major oil operator. Okay, like Aramco, if you look oil, many others. I believe Chevron, I saw they using it already. Exxon, if I'm not wrong. It's really good software. Okay. We are not biased for any software. We're just saying it's one of the best in the market. The presentation that you have provide, this is applied for single well or multi-well? Like if we
No,
have...
so GEOLOG is all multi-well. Okay. So whenever we are creating any FACE model, like say if you have 50 wells and you have 10 core wells, whenever we are creating a FACE model, okay, you can, when you are selecting the data, okay, like, say you are selecting data from what, so while building the model and while populating it, everything is multi-well. Okay. So when I
Okay.
add, I can just go and choose, uh, 3 well for modeling or 4 well or 10 wells for modeling. So it will take all the data from all the wells to model. Okay.
This will
So
enhance the prediction and machine learning if you
yeah,
increase
yeah,
the
yeah,
number.
yeah, more because the more data you have, sometimes what happen is that if you have, 3 reservoir in your area, and some will encounter only 2, the other encounter the other 2, and if you are building a model, only one well will not help to build a model, train the data. So you need multiple wells for the modeling. And once the model is ready, you can run it as in 5,000 well also in one go. Okay. So that powerful it is when it comes to multi-well, display, multi-well calculation, everything. Yes.
Really, really powerful. My other question, if we have like a field database, okay, and we want to automate the interpretation, like you have the database already for GEOLOG, and you want to make what I believe you called it unsupervised learning, something like that. But my question is like if we have this full field database, can, for example, we upload just the raw data for a new log data set, and the GEOLOG can automate the interpretation based on nearby results?
So yes, as I said, even if it is like, the normal petrophysics, okay, we have determined petrophysics. You know that whatever analysis you do, even if you are not doing machine learning, whatever model you create for basic log, like say B cell porosity saturation, in GEOLOG there is an option to save the parameters. Okay. And you can, when a new well is drilling, just load the basic data, open this model, restore the parameter, click OK, and then you will get all the interpretation. Okay. Now there are some other things, I don't know, I should call it machine learning or not as such, but there are certain other things like, we call it recording option. Okay. You can see I have started recording here. So whatever module I open here, okay, whatever input parameter I give here, okay, whatever I choose, it record everything. Okay. And when I'm done running this workflow, then I'm opening a layout for interpretation. Okay, that what interpretation I have done. So I can just open any layout. Okay, and I just stop this one. So what it will do is it will create a recording for you. Okay, so somebody who knows little bit of scripting, okay, can save this recording. Okay, save as. Okay, like I will write petrophysics. Okay, so you can see that uh, here we don't have define a well, so you can start from well, open a well and do the recording. It will just, and I can just run it quickly. So you can see when it's running, it will do the interpretation and open the layout automatically. So when it comes to automation, GEOLOG is quite powerful. It's not only the face image which can do, but I can just run a workflow which I have recorded, and it will run everything and open the layout for you. Okay, just
I
load
believe
the
this.
data and run it. Yeah.
Okay, this is great. So I believe this will reduce the using of logline, because like you doing some kind of interpretation, as you mentioned,
Right.
whether
Right.
was it deterministic or probabilistic. Okay, the program will record it, will create some kind of inner, let's say, what's coding for it. Okay,
Right.
okay, and then you whatever next value you load, it just will do the interpretation. Okay.
Right. You have to
Well,
just change the well name in that program. Okay.
mm,
There are people who can write a script. It will automatically take. It's based on how good we are. So in GeoLog we have multiple logging codes. That is one another thing when we talk about AI/ML. We have Loglan, we have Python, we have MATLAB, and we have something called TCL/TK. So this is what we are recording. Basically here is a TCL/TK script. Okay. So
mm,
whether you are opening up layout, whether you are running a model, whether you are running a loglan, whether you are running a multi-bin, this will record everything for each step, and it will do it for new well. Just change the well. The log name should be same, the set name should be same, and it will create everything for you. Okay. So
okay.
when it comes to AI/ML, Python is there. You can bring any Python code and run it in GeoLog. So that additional advantage in GeoLog when we run loglan. Okay.
Okay, great.
So
So
because
one,
other might have one option only, but you can see here we can run a Python code also. Okay,
great.
just
So
bring test and make a model and run it.
okay, some people asking for your email address. Okay.
Yeah.
So if somebody want to like enhance its experience with GeoLog, what's your recommendation? Any videos, YouTube channel, website, something like that?
Yeah. So I think there are some portals where they have some videos. I'm also there to help. We do a lot of webinars like what you're doing, and what I
Okay.
can do is every time I get that, I can forward it to you an SPWLA chapter which can be circulated through the chapter. Okay, I think almost every month we are doing some kind of webinars on GeoLog, so that will also be quite helpful, which is recorded also, so those who are attending can have the recording also. So we can collaborate with SPWLA Iraq chapter to send the invitation directly so that it can be circulated. So kind
Yeah,
of a
that will
part.
be great. Yeah, it will be shared in our channel. That will be great.
And
One
as I
last
said,
question.
yeah, and one more thing, if you are already user of GeoLog, remember, okay, there is a help file, okay, and there are a lot of videos here, okay.
Yeah, that's a great file. I
Yeah,
always use
so
it.
yeah, or flow zone indicator. So I can just open the video, and it will help me how to do the rock typing, wind
Yes.
land treatment, everything. So a lot of study material, but when you have access to the software, definitely.
Yes.
Okay.
Okay. One last question from Viney.
Mhm.
Viney, can this recording TCL run in other software suites?
No, because TCL is a special programming language. Okay, it is very advanced one. Some software like TechLog is mainly used Python. Okay. So this recording, this TCL scripts cannot be used in any other software because this is USB to GeoLog basically.
Okay, well noted.
Yeah.
So thank you, Brijesh, again. Any last word, Dr. Mohammed?
Yes, Mr. Mazen. Dear Mr. Brijesh Kumar Singh, again, on behalf of the SPWLA Iraq, we extend our sincere appreciation for your insightful and informative presentation. Dear attendees, thank you for joining us in today's webinar. We truly value your ongoing interest and active participation. Wishing you all the best, and we look forward to welcoming you at our upcoming events. Goodbye.
Okay,
Thank you,
thank
Dr.
you.
Mohammed.
Thank you.
Thank you. So I'd like to thank again our Mr. Presenter, Mr. Brijesh Kumar, Dr. Mohammed Jawazen Al-Abidin, and our attendees. Hoping to see you in next SPWLA monthly meeting. Thanks all and have a great day. I will
Thank
conclude the
you.
webinar.
Bye bye.
Thank you. Bye bye.